Hello everyone, and welcome back to Mikey's Southeast Asia Research and Development Center and Toy Store. And my newest and bestest new toy is a 3D printer. This one is a Flashforge Creator Pro Dual machine. Quite a nice beast. I've already run it through one cycle just to see how everything works, and I lived through all the pain of all of those steps and all of that discovery. So what I'll do is I'll walk you through how to get from drawing something in 3D to then holding it in your hand. Of course, I'm just a newbie at this. I have 1 hour's experience with this machine so far, so don't expect too much, but it'll be a good introduction. The interesting thing about this machine is it's got 2 print heads. That's why it's called a dual. Right now it's set up with white plastic on the left and red plastic on the right. They're both a type of plastic called PLA. You could theoretically set it up with 2 different types of material, one on one side and one on the other. And I'm not even sure that you can actually run them both at the same time. That would be quite a complicated thing to try and work out with the 2 different plastics or the 2 different colors being built up into the same piece. So that's for another day. But okay, let's get started. Well, I've been intrigued in 3D printing for a while and never really got the chance until now. The only thing I've done before is I downloaded the 3D files for this model Tesla supercharger station from a generous guy on the internet who designed it and provided the files. Then I used a tool to upload them to a 3D printing service in Bangkok. They accepted it. I paid for it. 4 days later, it was back in my mailbox. It was a little bit rougher than I initially thought, so it took quite a bit of sanding to get to this point. And I picked up some pieces of aluminum tubing from a hobby shop here in town, but I think it came out okay. And the cool thing is you put a USB cable through it and you can charge your phone and pretend you have a Tesla supercharger on your phone. So I was looking around for 3D drawing packages on the web. Before I had used SketchUp, but I found that worked better for the woodworking pieces I was making because everything was square or rectangular with nice 90-degree angles, but 3D printing really lends itself to making smoother shaped, more realistic real-world objects. So I came across a product from Autodesk called Fusion 360, and it's free as long as you keep telling them you want it to be free every year as a hobbyist. If you're not making any money off it, or if you're a student, they let you have it for free. And it's extremely powerful and easy to use right from the start for a newbie all the way up to incredibly sophisticated models that I've seen them come up with. And I'll leave a link to the download down in the doodly-doo so you can download it yourself. And there was quite a helpful tutorial that I walked through. It's a YouTube video tutorial. It had some minor issues, but I managed to get my way all the way through. And in the end, what you do is you create this wax stamp. So in the olden days, say Game of Thrones, when you needed to send a letter and certify that it was you, you would dribble wax on the paper and then you would put your unique shaped stamp into it and send it off by Raven. So what the tutorial does is it helps you design one of these things. It's quite simple. You basically, I'm not going to walk you through it because you can see the tutorial, but you start with a cylinder and then you there we go. So you make this little star pattern in the bottom, and it's a recess, you can see from the way the highlighting works. And then you you use some of the other tools to make these gentle curved shapes, chamfers and things, so it looks quite nice as the model. So once you've got that all done, what you need to do to prepare it for printing is you go up here and you say 3D print, and what we're looking for is when it talks about STL file. That's the kind of file that the utility that comes along with my printer knows how to use. So over here in 3D print, you actually want to turn this off. Yeah, this is another issue. You have to select the object, then you go 3D print. See now how when you hover over, it looks like it's not enabled, but you hover over the OK button and it turns on. So we don't want to send to a 3D print utility. We just want to print this as an STL file. The help is not good. The user interface is clunky. I don't know when something works and when it doesn't, but what you do, you come up here and you save your STL file somewhere. I've already got it, so we'll just overwrite. We'll say save. Yep. So we now have our STL file. I'm going to close this down and then we'll launch the tool that actually talks with the printer. Okay, the tool that we use to load in the STL file and send it to the printer is called Replicator G. It's very quirky. In order to make it run properly, you have to run it as administrator, or when you try and load your STL file, it gives you an access denied error. So what we do is we load in our STL file and it displays it in the build space of the printer. Now you might see a tiny little yellow thing right there. That's because the scaling is way off. When I exported it out of the 3D program, it's 50 millimeters in length. Here it's not. So what I have to do is change the scale and multiply by 25. Now we have it. So this is basically your time to place your object into the 3D printer in the orientation in which you want it to be printed. The blue is the plate of the printer, and this is clearly not going to work for us because we're just going to get half a stamp. So what we need to do is rotate this so it is standing upright on the blue platform. So to do that, we want to apply some rotation, and we're going to rotate about the x-axis. So that made it just stand upright, but still half of the stamp is below the plate. Luckily, there is a button called Put on Platform. So if I click that, now the stamp is scaled and is resting on the platform. This is exactly what we want. So what we do now is we can click on Generate G-code. G-code is the, you might call it markup language that the printer natively understands. The printer doesn't understand STL, so we have to go from STL to G-code. So we click on this, and I'll say yes, save the model. And now we're going to go through some settings before we actually do our generation. We're going to go with the Replicator defaults, where you're going to use the right extruder, which is red. No support needed. There's a lot of esoteric stuff that has to do with very involved 3D models. We can basically just use the defaults. We're going to infill at 10%. This is interesting because if you look at that model, it's basically hollow. All we care about is the sides and the top and the little star shape at the bottom. But in order to give it some structural strength, it's going to generate a 10% structure on the inside. We can watch that as it prints. We're going to leave all this. We're going to leave all this. Feed rate and print temperature is good. The filament is 1.75 millimeters in diameter, and all of that default stuff works great. So let's start generating some G-code. Fine. Now I think what's happening is it's using a G-code generator plugin called Flashforge, which will generate 185 things that the printer looks at in order to move the print head around and start or stop extruding the plastic into the model. And now there's another step. So we had a carve procedure, we have a preface procedure, we have an inset procedure. Now we're working on the fill procedure. And I'm running this on a 3-year-old laptop, so it doesn't have a lot of CPU grunt, but it does the job for me. If you were doing a lot of this and working in very complex models, you would probably want some very serious CPU power behind your 3D modeling itself, and you really need to have a good graphics chip so that you can smoothly pan around in space and make your updates to the model. Okay, we did speed, we did raft, we did jitter, we did comb. Looks like we're coming to the end. We did cool, we did dimension, we did alteration, and we are done. Took 1 minute and 30 seconds to export the file. So we have our G-code. Now what we want to do is actually send it to the printer. So I have to turn the power on. And then an important thing here is we need to preheat the printer. There's 2 things that need to be preheated. Printer's playing a song as it beeps. So we check our machine type, we're Replicator Dual. We check our serial port. It's not seeing it. So what we need to do is rescan. We're going to come back here, and now we have COM5. So the program is now talking to the printer. And then what we need to do is connect the app to the printer, so the two are communicating back and forth. So we click on this button. Okay, we are now talking to the machine. The machine is ready, and it's already giving us real-time status on the temperatures involved. There's 3 interesting temperatures, each of the print heads plus the platform itself. So next thing we do is we come here to the control panel, and we tell it what temperatures we want to be running at. Grab my paper, and since this is PLA, we want to be running it at 210 degrees C on the right print head, which is red. Now you'll notice that it's giving us some temperature graphs right here, and it's bringing up the temperature here. The platform target wants to be, I have to find that. I think it was 100 or 110. And we can wait for the printer to warm up while I find that. Yeah, 110. So we'll go over here and we'll put 110, and it will immediately start ramping up the platform. There we go. We're not telling it to heat up the left print head, but just because it's in the same piece of machinery as the right print head, we're getting some extra heat there. Now, one thing it said on the side of the printer is when you're printing with PLA, you need to take the top plastic cover off and open the floor. So that's what I'll do now while we're warming up. Okay, we've now reached our target temperatures. The right print head is good and the platform is good, so we can shut this down, and then we come over here and we say build. Now let me push record on the GoPro. Okay, we're recording on the GoPro, so you can get a bird's eye view of what's happening. I'll definitely fast forward that for you because it'll take 28 minutes to print. I'll give you a feel for actually how quick the print head actually is, but it's so much work to do, it takes a long time. So, estimated build time 27 minutes. And note that I've already pre-fed the red PLA plastic into the print head, leveled the printing plate, so everything is ready for go. Now it's just zeroing itself, getting everything ready. What it's doing now is it's laying down a very thin layer of material to act as the glue between the object and the printing plate. And then after printing's done, you just peel that away and give it a gentle sanding. Okay, we are now printing the stamp. Okay, so I'm going to fast forward it for now, so you have an idea of how it all works. Okay, and we're done. So it lowers the printing plate and everything's going to start cooling down. Print time 25 minutes. Used 3.14 meters of filament, which is very interesting. That's pi. That's funny. So I'm going to let that cool down for a second. There's a tiny little filament still hanging off. It's warm to the touch, but not bad. I'm going to give it a few more seconds because I don't want to mess up the shape. Yeah, it's cooled down a lot. The platter is still roasting hot, 110 Celsius. You could boil water on that right now. Okay, so I'm just going to gently grab it and try and pop it off. There we go. So you can see this little waffly shaped thing is the hold down, but it looks pretty good. Let's take a look. Okay, let's take a look at what we've got. That's pretty nice. You can see the waffle thing on the bottom. Let's peel these off. That's a hazard of having an open area right on the base of your design. But you can kind of see the star shape coming out. And I've also got some sandpaper that I'm going to work on here. I'll bring it in really close, give you some good light. You can quite clearly see the layers, although they're incredibly small. The tiny, tiny layers. You can hear them on the knife. Very small, but they're there. One thing I did notice is right here. It might be hard to see. Let me put it in profile. This bump right here, because when it started in this position, when it started going up, it it was putting layers on top that were unsupported right at the very edge from the layer below. So we got a little bit of sag here. That's probably tunable in the settings. I'm not sure, but it looks like one layer slipped down right there. And I may be up against the fundamental limit of how small a filament it can extrude, the resolution of the stepper motors that actually drive the print head, and the nature of the plastic. The plastic has melting point, cooling point, minimum filament size, and all kinds of other material sciences things that go into tuning the filament for the object you're trying to print. Now this is it's called a Pro, but not necessarily something you'd want to have as a production device at your business, but it's certainly good enough for hobby use and small runs for prototyping perhaps. Let's take a look at it through and see. You should be able to see some of the internal structure where I was talking about that scaffolding, or whatever the term was, the 10% where it didn't completely fill it in. But you can see some of the bars that it created internally to give it some strength. So it's still very solid, but not completely solid. It's like a chocolate bunny at Easter time. But overall, I'm pretty happy. I like it. Now let me sand the bottom a little bit and we'll see what we come up with. Okay, after a couple of minutes with some sandpaper from 220 up to 2000, got the bottom cleaned up, looks pretty good. Certainly good enough for a wax stamp demo project. So overall, I'm very happy. Thanks to my friend Hans, who initially bought the printer and didn't use it very much, so decided to sell it to me. I will give it a good home and make lots of fun things with it. So we'll just see what comes out next. If you have any comments or questions, just put them down in doodly-doo, and we'll see you next time.